In this video, we're going to talk about subsetting data objects. Some people may refer to this slightly different. You may know this under the subject of indexing, or also under the label of subscripting. All of this is the same. I'm going to be using these terms interchangeably, subsetting, indexing, subscripting. And the main idea has to do with that type of basic data manipulation operations. So this is the core idea behind subsetting data objects in R. Let's just start with a brief reminder of data objects, the main data objects that we've seen so far. And I'm just going to divide them into two big classes. On one hand, we have the so-called atomic objects. And then, of course, on the other side, you would place the non-atomic data objects. Examples of atomic objects. The first most basic type of object in R, as you know, is vectors. I'm just going to draw a picture of what a vector could look like. Then we have matrices. Let me call this MAT. So as you know, a matrix is a rectangular grid, a rectangular array. We could also think of arrays in general. And let me draw something like this, some sort of three-dimensional object. And let's include a couple of lines indicating that each of these slices also contain a two-dimensional structure. So let's write the dimensions: vectors, 1 dimensions, matrices, 2-dimensional objects, arrays, n-dimensional things in general. Remember that a matrix is a special type of array that has 2 dimensions. So this is what we have on the side of atomic objects. What about the other side with non-atomic things? So we have lists, let me call them LIS just to abbreviate things. And the picture is a set of non-contiguous, let me call them cells containing data. So that'll be something like this. And of course, we have data frames. Let me abbreviate them as DAT. And just to highlight the rectangular structure of data frames, similar to matrices, I'm also going to draw what would be the columns of the data frame, but separately, just with a slightly separation, so that, again, you remember that a special type of list are data frames, so that we have the discontinuity in terms of the elements in a data frame. List, you could say that these guys are also one-dimensional objects, whereas data frames, we say that these are two-dimensional objects. So in this sense, there is sort of like a relationship between vectors and lists, because both are one-dimensional things. And then also there is a relationship between matrices and data frames in the sense that they are two-dimensional objects. So how to manipulate data objects in R, generically speaking? I'm going to start with what I personally call bracket notation. And you'll see in a minute why I'm referring to this with this name, bracket notation, because we're going to be using brackets, the square brackets. Let me start with just a set of single brackets. Say you have a vector, or you could have a matrix. Both of these are going to be atomic. You could also have a list, let me call it LIS. You could also have your data frame object, DAT. Using single brackets next to the name of your object, whether it's a vector, matrix, list, data frame, right? So you have a set of single brackets in each case. So let's include those single brackets. And then depending on the dimensions of the object, remember vectors are one-dimensional things. In general lists, you could also think of them as one dimension, matrices, two-dimensional objects, similar to data frames. So depending on the number of dimensions, you're gonna place inside the brackets, you're gonna place, let me refer to this as an index, IND, for an index. as an index vector. Same thing with lists. So what you would specify is an index vector. If you have a two-dimensional object, then what you need to specify is a pair of index vectors. I'll refer to this just for illustration purposes as one vector for the rows, another vector for the columns separated by comma, and same idea for the data frame, a vector that allows you to subset or control what you do with the rows, and then another vector separated by comma that indicates what to do with the columns. So this is, again, the generic form using bracket notation that allows you to specify a vector, an index vector or indexing vector inside the brackets, the single brackets of either a vector, a list, matrix, and data frame. Now, what about a generic array that is not a two-dimensional thing? That would be a matrix. So in general, n-dimensional array, well, then you would specify as many indices. So let me call it index 1, comma, index 2, comma, et cetera, till index n, big N. Again, as many indices as dimensions in your array. And it's the same idea using pair of single brackets, separating indices by commas. So let's go over a set of simple examples. Let me start with a vector, and here let's define a vector vec with, let's say, 4 elements. It's gonna be a numeric vector. Remember, typing numbers like these, R will store things with a double data type. And we have 2, 4, 6, and 8. And again, if I want to manipulate it, I need to use a pair of single brackets, and then inside the brackets indicate an index and vector. Perhaps the simplest thing to do would be to start with a single index, number 1. And what this will do is basically just extract the first element, the number in the first position, which is going to be 2. So that's one simple example. Let's do another example by, let's say we're going to extract the first column 3. So I'm passing a vector with 3 elements. It's a numeric sequence from 1 to 3. And what this will do is it's going to give you, again in pictures, the first 3 elements, first 3 numbers in vector V, which is going to be 2, 4, and 6. Same idea, we could also take our vector, specify a set of brackets, and let's say I want to provide an indexing vector. It's going to be numeric vector. Let's say starting with the second position and also the 4th position. So basically skipping the first and the 3rd position. The output in this case will consist of a vector with the second element 4 and the last one 8. You could also specify vectors with negative numbers, for example, -2. And what this will do, every time you have negative numbers, you're gonna exclude them. So let me write it here. This represents exclusion. So basically the output will be a vector of 3 elements. So containing the first one 2, we're gonna skip the second position, and then the third one 6, the fourth one 8. What if you want to exclude more than one element? Well, for example, you could specify inside a vector, let's say we want to exclude the second, and we also want to exclude the 4th position. That's one way to do this. And the output in this case would simply be the first one 2 and the third one 6. Interestingly, you could also specify indexing vectors. Let me do something like this. Say the 3rd element, and let's repeat this guy twice. And just for illustration purposes, let's include the first one. So you could also do something like this. The output will be a 3-element vector. Again, repeating the 3rd value, that's going to be 6 twice. And then the first one, that's going to be 2.